Negative mass and its weird implications for reality. Imagine a world where everything you know about mass and movement gets flipped upside down. Imagine pushing an object, but instead of it moving away from you, it moves toward you. This is the bizarre reality of negative mass, a concept in theoretical physics that challenges the way we understand the universe and forces us to question the very laws of nature. Negative mass isn't just an obscure theory. It opens a Pandora's box of weird and mind-bending possibilities that could change our understanding of reality itself. What is negative mass? To understand negative mass, let's start with what we know: positive mass. In physics, mass represents the amount of matter in an object and determines how it responds to forces. Newton's second law tells us that if you apply a force to an object with mass, it accelerates in the direction of that force. This simple principle forms the basis for much of what we observe in the physical world. Push a ball, and it rolls forward. Pull a chair, and it comes toward you. But what if the object had negative mass? In this scenario, the rules change dramatically. If you apply a force to an object with negative mass, it accelerates in the opposite direction. Imagine pushing a negative mass object away from you, and instead of moving away, it zooms toward you, almost as if it's deliberately defying your expectations. This isn't just theoretical fun. It has real implications that challenge our understanding of the laws of physics. Runaway motion, a strange phenomenon. One of the strangest implications of negative mass is something called runaway motion. Consider what would happen if you put a positive mass object near a negative mass object. The positive mass is attracted to the negative mass, and the negative mass is repelled by the positive mass. This leads to an endless chase, with both objects accelerating together in the same direction, seemingly gaining energy without an external source. This process could theoretically go on forever, violating our current understanding of energy conservation and stability in physical systems. Runaway motion is a paradox because it implies that there's no resistance, no energy loss, and no end. If such behavior were possible in the real world, it would redefine how we think about forces and energy, creating a universe where limitless acceleration is possible under the right conditions. The role of negative mass in theoretical physics. Negative mass is not just a curious idea with no practical value. In fact, it plays a significant role in some of the most speculative theories in modern physics. The concept of negative mass is often linked with the idea of exotic matter, a hypothetical form of matter that defies the norms of positive mass. Exotic matter is theorized to be essential for phenomena like wormholes and warp drives. Warp drives. In the 1990s, physicist Miguel Alcubierre proposed a theoretical model for faster-than-light travel, famously known as the Alcubierre warp drive. This concept relies on manipulating space-time itself to create a warp bubble, a contraction of space in front of a spacecraft and an expansion behind it. To do this, the warp drive requires a type of negative energy, which could theoretically be provided by negative mass. The negative energy density would allow space-time to bend in unusual ways, creating shortcuts across vast distances in the universe. While this concept is purely speculative at this stage, the idea that negative mass could facilitate faster-than-light travel is a tantalizing glimpse of what could be possible in the distant future. Wormholes. In a similar vein, negative mass is also theorized to play a role in stabilizing wormholes. Wormholes are like tunnels through space-time that could potentially connect distant parts of the universe, providing a shortcut for travel. However, most solutions in general relativity suggest that wormholes are inherently unstable and would collapse almost instantly. Negative mass could act as a stabilizing force, preventing the collapse and keeping the wormhole open, thereby allowing traversable paths between distant regions of the universe. Does negative mass exist? The big question, of course, is whether negative mass actually exists. So far, there has been no direct evidence for naturally occurring negative mass in the universe. However, certain physical systems exhibit behaviors that resemble negative mass. For example, in 2017, researchers at Washington State University created a peculiar fluid with properties that acted like it had negative mass. When the fluid was pushed, instead of moving in the direction of the force, parts of it accelerated backward, just like a negative mass object would. While this doesn't mean we've found negative mass in a conventional sense, it shows that under very specific conditions, the universe can exhibit behaviors that mirror what negative mass would theoretically do. Could negative mass explain dark matter or dark energy? Some scientists have even speculated that negative mass could be related to dark matter or dark energy. Dark matter makes up about 27% of the universe and is responsible for the extra gravitational effects that hold galaxies together. It's invisible and doesn't interact with electromagnetic forces like regular matter. Since negative mass could have gravitational effects opposite to those of positive mass, it's been proposed as a candidate for explaining some of these mysterious cosmic forces. On the other hand, dark energy is the force driving the accelerated expansion of the universe. Negative mass, with its tendency to repel and behave oppositely to regular matter, could theoretically contribute to this effect. Although these ideas are purely speculative and haven't been confirmed, they highlight just how little we know about the universe and how negative mass could be the missing piece in our cosmic puzzle. Violations of fundamental laws. Negative mass presents serious challenges to some of the most basic principles in physics, like the conservation of energy. The idea that a positive and negative mass pair could accelerate indefinitely without an external energy source suggests a potential violation of energy conservation. This goes against the grain of what physicists believe to be true about how energy works. Such scenarios raise fundamental questions. Are our laws of physics incomplete? Could there be hidden factors or mechanisms at play that we have yet to discover? A universe full of paradoxes, the concept of negative mass challenges the symmetry and simplicity of our universe. If negative mass does exist, why have we never seen it? Is it because it exists in such a way that it remains hidden from us, or could it be interacting with the universe on a scale that we haven't yet comprehended? These questions push the boundaries of our understanding of space, time, and matter, suggesting that there could be aspects of reality that are far stranger than we could ever imagine. Negative mass, though entirely hypothetical at this point, gives us a unique window into how much we still don't understand about the universe. It forces us to rethink the laws of motion, gravity, and energy. It invites us to explore ideas like wormholes and warp drives and to consider whether there are entire categories of matter and energy that we haven't yet discovered. Whether or not negative mass is real, the implications of its existence are so profound that they remind us just how strange, mysterious, and exciting the universe truly is. Call to action. If you're intrigued by the mysteries of the universe, don't stop here. Dive deeper into the world of theoretical physics. Like, share, and subscribe for more mind-bending content.